Hey guys, welcome to this special video on the unit circle. So before we get into this guy that I've got right here, we're going to talk about what in the world is a unit circle. Whenever in mathematics we talk about unit, what that typically means is kind of our standard multiplicative identity, which, for those of you who aren't aware, 1. So when we say unit circle, what we mean is basically, very simply, a circle with a radius of 1. So if we draw that out, okay, so our radius is 1. What's really cool is that means this point right here is 0.10. This point right here is 0, 1. This point here is -1, 0. And this point here is 0, -1. Okay? Now, if these are on xy axes, right, then if we look at any angle on here, okay, let's just say some arbitrary angle theta. Okay. This point right here, this x comma y, well, it's on this unit circle, which means its radius, sorry about that, which means the radius equals 1. So if we're on this unit circle, well, sine of theta is equal to y over r. But if r is just 1, it just equals y. Cosine of theta is x over r, which is just x. Tangent is the same, cotangent is the same, it's still y over x and x over y. But cosecant of theta is now just 1 over y, and secant of theta is 1 over x. So we get these really cool things. And so that is really beneficial and helpful to us. And so being able to think about things on the unit circle means we don't have to worry about these radius. We just have to worry about whether or not the x value or the y value is positive or negative, and then whether we're dealing with sine, cosine, or tangent, whether we're dealing with the x, y, or both. And so let's look down at this very important thing. This is called the unit circle. This is something that you need to fill out and you need to print off, fill out, and have out with you anytime you're working on this class. 90% of the things we do in this class, having the unit circle either memorized, if you're that good, or just available to you readily right there, will make so much easier. So the first thing is, I want you guys to read these instructions, okay? We're going to place the degree angle measure, the dashed lines, and the radian measure of the angle on the solid lines. So if we just look here at this first quadrant, okay, we have 5 angles, if you will. We have the angle that is 0 degrees. We have this angle here, this first one here, which is 30 degrees. The second angle is 45 degrees. Our third angle is 60 degrees. And this last angle here is 90 degrees. Now, the 0 and 90 degrees are obvious ones, but when we look at the other, 30, 45, hey, we have that table that does these things for us. So we're going to be able to use that to help us out with this, okay? And these originate in much the same manner. Now, for the radian measure, we have 0 radians, because 0 degrees, 0 radians are the same, which is really nice. This is pi over 6, pi over 4, pi over 3, and pi over 2. And so then what we do is we can kind of fill in this whole circle. And so I want you guys to make sure to be able to do that, okay? And these are values, these angle values are things you need to be able to recognize fairly quickly. Okay, so we have 120 degrees, 135 degrees, 150 degrees, and 180 degrees. And so that is 2 pi over 3. This is 3 pi over 4. This is 5 pi over 6. And then this is just pi. Okay? So I want you guys to be able to do this. So I want you guys pause this video, fill in the rest of these angles, and don't play this video until you are done with doing that. Okay, so pause it now. Go ahead, pause it. Come on. All right, welcome back. Thank you guys for doing that. For those of you guys who have just sat out and listened to me say pause it now a couple times, shame, you guys. Come on. You got to engage with this material, work with it. For those of you that did, awesome. Thank you. Congratulations. So we're going to go through and do all of the degrees, and we'll come back and do all of the radians. So go 210, and then 225, and then 240, 270. Notice that the outer ones jump by 30 degrees each time. So if we kind of go here, we went 0 degrees, 30 degrees, 60, 90, 120, 150, 180, 210, 240, 270. So those are all jumping by 30s. 0, 45, 90, 135, 180, 225, 270. That's all jumping by 45. So you can really break this up into kind of two sets. We've got the 30-degree jumps, and then we've got the 45-degree jumps. And so those are kind of how these can be kind of thought of in a quicker manner. So 300 degrees, 315 degrees, 330 degrees, 360 degrees. All right. Now, another way to think about this is that the first jump here from 0 to 30 degrees is a sixth of a pi. And then, so every 30 is we're adding 1/6 of a pi, and that can simplify each time. But so what's nice is we can kind of think of it like when it's closer towards the 1 on the y-axis, we're looking at third, it kind of decreases. So we went 6, 4, 3, 2. And so what's nice is, it means this one here is going to be an over 6. Matter of fact, it's 7 pi over 6. 5 pi over 6. Add another 6, we get 6 pi over 6, which is pi. Then 7 pi over 6. So that means that this one here is going to be fourths. So this is going to be 5 pi over 4. That's pretty ugly. 5 pi over 4. And this is going to be 3. So we're going to get 4 pi over 3. And then 3 pi over 2. And now we go back up. So if this was 4 pi over 3, okay, the next would be 5 pi over 3. This was 5 pi over 4. 6 pi over 4 is just 3 over 2. So then this would be 7 pi over 4. And then this last one here is a lovely 11 pi over 6. And then nice 2 pi. So there's all of our angle values in there. And now what's really cool is that this just follows the same quadrant rules. And so, I mean, we can really easily fill these in here. So let's get those filled in. Okay. But the quadrant rules all apply. In quadrant 1, both x and y are positive. In quadrant 2, the x is negative, y is positive. In quadrant 3, the are both negative. In quadrant 4, the x is positive and the y is negative. And what's really cool is that can tie into our trig functions. In quadrant 1, all of our trig functions are positive. In quadrant 2, where we have negative x values, it means our cosine is negative. If cosine is negative, that also means tangent is negative. Cosine is negative and sine is positive means tangent is negative. Quadrant 3, both sine and cosine are negative, but since those are both negative, tangent is positive. Quadrant 4, our sine is negative, our cosine is positive, so that means our tangent is also negative. So we can really get some cool kind of things like that. We can see just based on where the graph is at, where the angle is at, which quadrant it's in, whether we know whether sine, cosine, and tangent are going to be positive or negative. So that's really cool. So I'm going to fill in this first quadrant. And then what I want you guys to do is I want you to fill in all the rest. Okay. So we get root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, and root 3 over 2. Now you may be wondering, how in the world did I know all of those? Right? That is that table that we did in 6.2. So if this is a 30-degree angle here, Okay. Sine is our y value, and sine of 30 degrees is 1/2. Okay. So we get that very simple way to do this. Now, what's cool is this is all symmetric. So if you imagine folding this unit circle along the y-axis, okay? Erase that because I don't want that actually on there. Then this point here would fall right to here, which means the x and y values would be the same numerical values. So this would still be 1/2 and √3/2. But what we have to account for is the quadrant we're in. Since we are in the second quadrant, that means our x values are negative. And in this second part here, we have √2/2, √2/2. Again, the x value is negative. And then here we have negative √3/2, 1/2. All right, from here, I want you guys to finish this whole thing out. This is something that is extremely important for you guys to know forwards, backwards, left, right, center, and to be able to utilize this. Now, that does not mean that you have to memorize, right? Knowing is not memorizing. Knowing is being able to, if I say, what's sine of 5π/4, it shouldn't take you 6 minutes to find where 5π/4 is. You should be able to quickly jump to it, quickly acknowledge that sine is the y value. 5π/4 is in the third quadrant. Therefore, it is sine of 5π/4 is negative 1/2. And it should be that fast for you. It also wouldn't be a bad idea to look at these values. So for tangent, okay, so the values we have possible are 1/2, √2/2, and √3/2. Okay. For a tangent, we can have a ratio of some of these. Now, we can't have 1/2 over √2/2 because those aren't involved in the same angle. For tangent, we could have 1/2 over √3/2. We could have √3/2 over 1/2. And we could have √2/2 over √2/2. It's a good idea to know what these simplify to very quickly. Ooh. Okay. With these first two, the easiest way to do it is to use the idea that dividing by a fraction is multiplying by the reciprocal. So 1/2 over √3/2 is really just 1/2 times 2 over √3. Our 2's cancel. I get 1 over √3, which that simplifies or rationalizes by multiplying by √3 over √3 to be √3/3. We do the same thing here. We get √3/2 times 2 over 1. Our 2's canceled. √3/1 is just √3. Now here we could do that, or we could acknowledge the fact that we have √2/2 divided by √2/2. So we have the one thing divided by itself, and that's just 1. So there's our 3 tangent values for these angles, give or take their signs. So make sure that these are some things that would be really important for you guys to maybe know, have written down, maybe utilize this space down here to write things like that, and go from there. All right, you guys, pause this video, do this. I'm going to wait a few seconds, and I'm going to fill this in for you. So go ahead and pause the video right now. I want you to try and fill this in by yourself. I can guarantee you that I will have you do something like this on a test. So get after it. All right, there you have it. There is your complete filled in unit circle. I cannot emphasize how important it is for you guys to be able to know and use this forwards, backwards, left, right, center, and to really understand what's happening here. That's it. I will see you guys next time. Have this ready with you next time, and we'll talk about it. Or maybe we won't. You'll see. See you around.